All right, so I think let's recap from here where we're talking about getting these exact angles. So I was saying you must use the you must use this triangle where I'm saying this is 60 degrees and that is 60 degrees, 60 degrees, and this also is 60 degrees, but then we're having a line that's splitting this angle. We're saying to 30 and there 30. So this part here in between that line is saying root 3. Root 3, and that is 2, and that is 1 there. So now, from here, we're saying arctan is just the same as saying tan inverse. So, tan inverse of root 3. To get the exact value of this, what we're looking for is the angle. What angle does this correspond to? So, because we gave an example, say if we have tan theta, so you have tan theta like that, then it's x over what? Y. Then we say theta is equal to tan inverse of x over y. So now they've given us this part here. Then they want us to find that angle. So we need to find the corresponding angle. So now in terms of what? Of tan. So tan is just opposite over what? Opposite over adjacent. So you must get an angle here that will give you that value. So if we get this angle here, which is 60 degrees, and we say the opposite of this here is where we have root 3, then the adjacent is just 1. So this here, when we say tan 60 degrees, is going to give us root 3. So now, which means tan inverse of root 3 is equal to what? 60 degrees. So there the value arctan 3 is just equal to 60 degrees. So that's how you get that angle there. And of course, in our question, we see that that is positive. So now let us get the one that follows next, which is arcsine. So to get arcsine, what we do, we will say, so arcsine is the same as we're saying sine inverse of, so negative root of 3 over 2. So now you check this now in your diagram, which one is going to give you this one. So we know that sine, if we have sine, is just opposite over hypotenuse. So your opposite in this case of the same angle, if you see 60, your opposite is root of 3. And your hypotenuse is just 2. So this means this corresponds to the angle 60 degrees. So this is sine 60 degrees, which is equal to root of 3 over what? Over 2. And this is just going to be 60 degrees is equal to sine inverse of root of 3 over 2. But as you can see in our question, we have a negative there. So meaning this angle is what is negative if we have that negative there. So now if we were to write it, if we were to sketch that angle like that, meaning I would move not there anti-clockwise, but I'll move clockwise 60 at an angle of 60 degrees. So that angle from there to there is going to be 60. So now I have to get that when I move from the positive x-axis till I touch that vector, what angle will this make here? That angle. So when I get that angle there, this angle here is going to be what? It's going to be 360, then minus what? 60 there. Then this gives me 300 degrees. So which means that arcsine negative root of 3 over 2 is just equal to 300 degrees. So that's how you get your value there. Okay, I don't know if there are any questions on this one. All right, so we move on. We have this here saying find the limit. So if you observe that when you have this, the limit of x as it approaches 0 of this function here, x plus 5 minus root 5 over x. If you are to plug in 0 here, you have 0 in the bottom and this becomes undefined. So meaning you have to have a case where you won't have 0 in the bottom. Now, how do we do that? So to do that, we have to rationalize this denominator. We must multiply the numerator by its conjugate. Yeah, multiply the numerator by its conjugate, and you have this would be root plus 5. So there the negative will be positive, and that will be 5. And we do the same in the what? In the denominator. So that gives me 5, like that. So I'll have the limit as x approaches 0. Here, what will I get? So it will be this squared. So this multiplying with that, I'll just get, I'll have x plus 5. Then there I'll get minus 5 over x, which is going to be multiplying by x plus 5, like that here. Then plus we have 5 there. So this is going to be equal to the limit as x approaches 0. So 5 minus 5 is 0. I'll just remain with x there. Then down I have x root over x plus 5 plus root of 5. Then those x's can divide. So when they divide, I'll just have the limit as x approaches 0. It's going to be 1 over, then I'll have root x plus 5 over root 5. It's plus here. Then I can replace my 0 now in that equation, and I'll just have 1 over. So when I put 0 where x is, that gives me 0, and I'll plus 5. That would be root of 5 plus root of 5. And this here is just going to be 1 over 2 root of 5. So that's the limit there. Okay, the last question is this one. It says determine whether or not the function f of x there is continuous at 2. So we can graph this function. So we have that is x there, and we have y there. So let's look at the first equation. Is 7x minus 2. So this is y equal to that. So we can find our y-intercept. So our y-intercept is just going to be y equal to -2. So meaning the graph cuts y at -2. Our x-intercept when y is 0, x is just going to be x equal to 2 over what? 7. So that's what we get. Then we can do the same for the other equation, 3x plus 5 there. So we say this is our function, this is y equal to that. Then our y-intercept when x is 0, that's y is going to be 5. And our x-intercept is just going to be x equal to -5 over 3. So this is where they are cutting those axes. So then I have a point, of course, 2, which I have to check if it's continuous at that point 2. So now you can plot this. I'll say y equal to -2. Let's say it's down there, and it's going to cut through maybe that point there. Okay, and I can get a corresponding point here, corresponding point of this 7. So I have 7x minus 2. So when I check f of what? F of 2 of this part. So when I place 2 there, I get 14 minus 2, and this gives me 12. So I get 12 there. So meaning this corresponding point is going to be corresponding to 12. So this here is going to be our 12. When I do the same for the other one, I get 3 multiplied by 2 plus 5. This gives me 6 plus 5, which is going to be 11. So here I see that there's an equal to, meaning it's what? It's a close at this point. So I can connect from there like that. So this is my line for the first one. So meaning here where it's cut, that's a point, our x-intercept, which is 2 over 7. Then I can have the other line, which cuts through negative 5 over 3. And it's 1, 2 corresponding to what? To 11. So let's say 11 is there. So it's here. And it's open there because the 2 is not equal to there. Then it's going to be, then it passes through, so it passes at y is equal to what? To 5. So let's say there where it cuts, it's y equal to 5. And there is negative 5 over what? 3. So they're telling you to find, to check if this is continuous at 2. So to check that it is continuous at 2, you must check first of all if the function at f is equal to 2 exists. So check if it exists first at f equal to 2. So now we see the point where we have an equal sign, this part here. This is where we have an equal to, and x is not part of, 2 is not part of this other one because there's no equal sign equal to there. So here where there's an equal to, meaning you use that equation there and you replace. So you say f of 2 is equal to 7x minus 2, and replace where x is. You have 2 minus 2, and you have 14 minus 2. This is equal to 12. And 12 exists because 12 is part of this versus graph. It's part of this one. So it will be defined at that point. Now, the next thing is you have to check if the limit what exists. So the limit of x as we approach 2 of the function, so the function f of what? X. Does this limit what exist? You have to check. So for us to check if it exists, meaning we must there, when we approach 2 from the right side, this must exist and it must be equal to the limit as x approaches 2 from the negative side. This also must what? Exist, and they must be equal for the limit to exist. So we see that when we're approaching from the right side, we're approaching 2 like this from this side. So the function approaches what? This point here. It's closed at this point. So we see that as we approach 2, the function goes to what? To 12. So from the right side, the limit as we approach x from the right side like that of f of x, this is going to 12. Now, when we check it from the left side, as we are approaching 2, like that from this side, you check, does it give you the same values as this one? And moreover, the entire thing is defined by both of these uh, both of these uh, both of these functions that are here, both of these equations that are here, they make the entire word function. So when we approach it from this side, we see that, okay, yes, of course, there's this part where it approaches 12, but we see that there's the other value where we're getting that it's going to be what? To be 11 at that point. At that point, it's going to be approaching what? 11. So when you get values in between here, you have to check if it's going to what? To approach those, if it's going to be valid at that point. So, of course, for this line, the one which is closed here, it's going to give us 2. But for this other line, when we approach it this side, when we're approaching this side, it's not giving what? It's not valid at what? At 2. When we're approaching it this side, we see that it's not valid as well at 2 because it's open here at 2. Of course, it gives us 11 there, but this other side, we see that it's what? It's open. So which means that this limit the limit here does not exist, because it gives us, or it approaches different values. When you approach that side, it gives you 12, the other side gives you what? 11. So this means that it does not exist. And since this part here does not, the limit does not exist, which will show now that this function is not continuous at the point 2. The function will not be continuous at the point 2. So for it to be continuous, both of these had to be what? To be true. This first one, when you plug in that, and the limit has to be approaching the same value for this function. So now we see that it's giving us different values. Thus, it won't what? It won't exist. So it is not continuous at 2. Okay, this is how we do this question, and this marks the end of this tutorial and this paper. I don't know if there are any questions.